Question number 12. A charge Q is placed at the center of an uncharged hollow metallic sphere of radius A. Find the surface charge density on the inner surface and on the outer surface. If a charge Q is put on the sphere, what would be the surface charge densities on the inner and the outer surfaces? Part C. Find the electric field inside the sphere at a distance x from the center in the situations A and B. Here, charge Q is there. This is sphere, and this is a hollow sphere. So, due to induction, here on inner surface, charge will be minus Q, and on the outer surface, charge will be plus Q. Now, case number 1, find surface charge density on the inner surface. So surface charge density on the inner surface will be sigma 1 equal to charge is minus Q divided by surface area of the sphere 4 pi A square because the radius is A. And surface charge density on the outer surface will be sigma 2 equal to charge is plus Q divided by 4 pi A square. Now, when charge Q is given to outer surface, it will remain on outer surface only, and in the inner surface, only minus Q charge will be there. So, in this case, surface charge density on the inner surface will remain same, that is minus Q upon 4 pi A square, and on the outer surface, since charge is plus Q, capital Q, and plus small q. So surface charge density sigma 4 is capital Q plus small q divided by 4 pi A square. Now, electric field inside the sphere will remain same because this outer charge will contribute nothing to give electric field inside. So we can say that electric field here V being outer charge is that charge which is being given. So here E will be due to the inner charge plus Q only. So Q divided by 4 pi epsilon naught A square. So a contribution of small q, which is given later, will not be included or will have no contribution. Consider next question. Consider the following very rough model of beryllium atom. The nucleus has 4 protons and 4 neutrons confined to a small volume of radius 10 to the power minus 15 meter. The two 1s electrons make a spherical charge cloud at an average distance of 1.3 into 10 power minus 11 meter from the nucleus, whereas the two 2s electrons make another spherical cloud at an average distance of 5.2 into 10 to the power minus 11 meter from the nucleus. Find the electric field at point A just inside the 1s cloud and B a point just inside the 2s cloud. Here, the electron cloud due to 1s electron is shown here, and due to 2s electrons, it is shown here. And the radius is also given. Radius of the nuclei is Ra. Radius of the orbit of 1s electron is Rb, and that of 2s electrons is Rc. Now, we have to find out the total charge. So total charge, since it contains 4 protons, so charge, positive charge will be, suppose this is Q, so 4 times protonic charge, 1.6 into 10 to the power minus 19 Coulomb. Now, electric field just inside the 1s cloud. So electric field here, just inside the 1s cloud, electric field just inside the 1s cloud will be due to these protonic charges. So we can say it as E1. So 4 protons, 4 into 1.6 into 10 to the power minus 19, applying the formula E equal to Q upon 4 pi epsilon naught R square. So Q is 4 into 1.6 into 10 power minus 19 Coulomb. into 9 into 10 to the power 9 divided by separation. So distance RB is given as, here it is given as 1.3 into 10 power minus 11 meter. So 1.3 into 10 to the power minus 11 whole square. So we can simplify it. So it will become 4 into 1.6 into 9 divided by 1.3 into 1.3 into 10 to the power, total power minus 19 plus 9 plus 22. So this will become minus 19 plus 9 plus 22. So if we simplify it, we will get 3.4 into 10 to the power 38 Newton per Coulomb. Now consider the second case. Electric field just inside the 2s cloud. So this time distance will be RC, and RC will be 5.2 into 10 power minus 11 meter. And net charge due to these 4 protons reduced by charge due to two 1s electrons. So net charge, say it is Q1, so that will be charge due to 4 protons, 4 into 1.6 into 10 to the power minus 19, reduced by 2 electrons, means 2 into 1.6 into 10 to the power minus 19 Coulomb. Here there are 2 electrons in 1s orbital, so their charge will be negative, and charge due to protons will be positive. So we are making the difference of the two, so that will be equal to 2 times 1.6 times 10 to the power minus 19 Coulomb. Now we have to find out the electric field just inside the 2s cloud. So this will be equal to E2 equal to charge 2 into 1.6 into 10 to the power minus 19 into 9 into 10 to the power 9 divided by distance. Distance is 5.2 into 10 power minus 11. 5.2 into 10 to the power minus 11 squared. So if we simplify, 2 into 1.6 into 9 divided by 5.2 into 5.2 into 10 to the power minus 19 plus 9 plus 22. So if we simplify, it will come out to be 1.1 into 10 to the power 12 Newton per Coulomb, which is our answer. Thank you for watching.